Today I'm gonna show you how to fix a bad driver IC on an LED module. So how do we know if it's the driver IC issue? Well, here are a few common signs. Sometimes you may notice a big weird block that color looks not right, or maybe a color missing block. That's usually a driver IC issue. Or you might see a brighter LED column, like a caterpillar line on the panel. That's also likely a driver IC issue. Also, if a large section of the screen display abnormal, it's probably the IC issue again. To repair it, what tools do we need? First, we'll need a set of soldering iron, but we need to change the tip to a thicker, wider one, like this one here. Next to it is the one for LEDs fixing. Of course, an electric screwdriver is necessary. The bit size is same as before, around 1.4 to 1.8 millimeters. Our bottom cover also has screws. The size is same as our mask screws. Next, we have our waterproof glue, and this injector is for applying the glue. It's mainly for outdoor screens. Waterproofing is necessary for them. Indoor screens don't need it. Then, solder wire. Size is same as before, 1 millimeter. And tweezers. And another self-made tool, which helps us easily remove the back cover. It's specifically for taking the back cover apart. The diameter of its threaded tip is about 1.9 millimeters. Finally, a test box and the IC chip will be replacing. Alright, now take a look at this module I'm holding. Let's see what kind of issue it's causing. First, power it on and test. When plugging in, be sure the arrows on both ports line up the same way. Now, you can see a big, bright red block right here. Let's run a quick RGB test. The same place still shows a large dim red block. Green is fine. Blue, okay. So it's probably a red channel issue, just like we mentioned earlier. A large bright block in red. And this issue is usually caused by one of the RGB driver ICs in that group. Now, let's replace the IC and fix this issue. Before that, we need to identify which ones are the driver ICs, which control the color signal output. Let's take this board as an example. This chip, the one in this group, is our driver IC. It manages the color output, and it usually looks like this. You may also notice other ICs on the board. These horizontal ones are the line decoder ICs. They're larger than the driver IC. The smaller ones are 245 ICs, used for signal amplification and buffering. But today, we're focusing on this one. The driver IC controls the color output, and it's what makes the color block happen. Let's learn how to fix it. Each pin on the driver IC has its own specific function. This diagram shows what each pin does. It's exactly the same one that we used on this board. This type has 24 pins in total. Different IC models may have different pin counts, but for this board, it's a 24 pins. You can clearly see the 24 pins right there. Some of them are marked as output pins. These are the ones that send color signals to the LEDs on the panel. The first 4 pins on each side can be ignored for now. We mainly focus on these 8 output pins on each side. 16 pins in total. Here, each output pin controls one column of LEDs, just like on this board here. Since there are 16 pins, that means one driver IC controls 16 columns of LEDs. If we count from the first to the 16th pin, we can roughly tell where this color block appears on the panel. For example, on this board here, the driver IC caused the bright red block, which is roughly located in this upper right corner. Here, I brought a bare board of the same model for comparison. This is the IC side, and this, LED side. Let's flip it over to align with the one above. Since the color block shows up here, it probably lines up with this area, one of the first IC group. If the issue shows up here, it's likely from the one of this IC group. If it appears lower down, then it's probably one from the group below. Now in this first group of ICs, we can see 3 of them here. They control the output for red, green, and blue. On the board, you'll notice markings like UR, UG, and UB, which mean the RGB color signal. Like the red color block you saw here, it means the red driver IC UR is likely faulty. But if this issue shows up somewhere in the middle, it may be trickier to find out. As so many ICs there, it's hard to tell which one is causing the issue. That's why understanding the pin definitions on these ICs is so important. Here is the pinout diagram of the driver IC we introduced earlier. This IC on the board has 24 pins in total. Among them, 16 pins are labeled as outputs, which drive the color signals to the LEDs. 8 pins on the left and 8 pins on the right, ignoring the first 4 pins on either side. As we mentioned before, each output pin controls 16-piece LEDs in total. That means one IC controls half a row of LEDs on this board. Since there are 16 output pins in total, so one driver IC can control 16 columns of LEDs. We can count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Exactly 16 columns. Based on this principle, if there's an issue in the middle, you can count LED columns and trace which IC is responsible. That helps you pinpoint the exact faulty IC more easily. Next, let's move on to the hands-on part. We're going to repair this board, but before we get started, we need to remove the back cover. The back cover is secured with screws, and those screws are hidden underneath the LED mask. So first, we'll need to take off the mask completely. For this module, already taken off the entire mask, so that part's done. Now, let's power off the board first, and start unscrewing the back cover by screwdriver. These cover screws are usually hard to spot at first glance, because they're hidden under waterproof glue, so you might not spot them right away. So how do we locate them exactly? Here's tip. Use the IC control area as a reference. One set of RGB driver ICs controls 16 columns of LEDs, and you'll typically find a group of screws between the 16th and 17th LED columns. Usually, there are about 5 screws here. Just remove them the same way like removing the mask screws. Make sure to keep your screwdriver perpendicular to the LED surface. Otherwise, it's really easy to strip. Since they're glued in, they're even more likely to strip. So press down firmly and stay straight when removing them. See how I do this? Press down firmly, straight in, then twist. It's already off. Okay, next one. This one here is already out. Now move to the middle. We've got 3 screws here. Usually, each IC control area has about 5 screws, about 16 LED columns in width, and they're usually placed roughly along the edge of the area that each IC controls. Alright, all screws are out. No many left on this panel, since I removed most of them earlier. And now, we can separate the back cover, but we need a special tool like this. It can help us remove the back cover efficiently. You can't buy it directly, but don't worry, it's easy to make. Just get a threaded tip like this and solder it onto a handle yourself. The IC board actually has pre-made holes specifically for this purpose. They're usually somewhere around the middle or near the 4 corners. Let me show you. I round this spot here with the tweezers. On some panels, the holes might be here or here. They're generally near the 4 corners. Now, take your self-made tool and gently screw it in. Just be careful not to damage any nearby LEDs while tightening. Try to screw it in firmly. Okay, done. Now, press down on the left side of the panel by your left hand, and pull outward by your right hand. And there you go. The PCB board is separated. Alright, flip it over. Now, you can see the ICs. Once that's done, we can start replacing the faulty IC. But there's one important thing that I haven't mentioned yet. The back cover is secured with glue. You'll need a bit of force to pull it out. If it still doesn't come out, you might miss a screw somewhere. So make sure all the screws are fully removed. Otherwise, forcing it directly could damage the LED board. If you don't have this self-made tool, tweezers can work too. Just slide the tip into the edge of the back cover and pry it out gently, but I wouldn't really recommend it. It's pretty easy to bend or mess up the edges of the back cover. You could also try using a blade, but that may scratch the PCB if you're not careful. Alright, let's begin to repair. I'll turn the board so the side I'm fixing is closer to my tools. First, turn on the soldering iron. Note that the temperature for IC repair is different from fixing LEDs. For IC, 370 to 400 degrees Celsius would be better. Otherwise, IC chip would be hard to remove. But don't be too high or too low. Too high temperature may damage the pads. I usually go with 400 degrees Celsius, and that works well for me. Okay, let's get started. When replacing the IC, be sure to add plenty of solder. Start by covering the IC pins on one side. Then do the same on the other. Don't be stingy with the solder. This helps the heat spread evenly and makes removal easier. Then, use the tweezers tip to gently nudge the IC from one side. Take it slow. No need to force it. And just like that, the IC pops right off. After that, clean up the pads. Make sure no leftover solder before you install the new IC. Now, let's install the new IC. Each IC has its own model number. This one is CFD433DA. So make sure you're using the right one. Also, pay attention to the orientation. There's a tiny dot on the IC corner. It should be facing the same way as the others on the board. Don't get it wrong, or the LEDs won't light up. Okay, let's align the IC pins with the pad on the board. Make sure all the pins are lined up properly. Then use the soldering iron to lightly press down the side. Just hold it in place, even if it doesn't fully stick yet. Now move to the other side. Add some solder on the surface, and press it down with tweezers. Then to this side, and add a bit more to heat it again, and press it down firmly. If there's any extra solder left behind, just clean it up. For beginners, this part may be a bit tricky. Here's a tip. You can use tweezers to gently press down on the IC. Then, once the solder melts, scrape outward by the tip of the soldering iron. Just be quick and apply a bit of pressure, like this. That usually does the trick. If that doesn't work, you can add a little fresh solder and try again. It'll come off much easier. Alright, that's it. The IC is replaced. Next, let's power it on and run a quick test. When connecting, look for this little arrow on the PCB. It needs to face the same direction as the one on the test box. Otherwise, it won't work. Here's the faulty spot that we mentioned earlier. And this is the IC we just replaced. Let's power it on. Red is okay. Green, okay. And blue, fine. Ignore this dead pixel here. Then white, fine too. Okay, let's run a scan line test. If you see two lines lighting up at once, that usually means some IC pins are shorted. In that case, check for the solder bridges of the IC pins. Another issue is, if the white area looks a little brighter than other areas, that could mean the IC wasn't soldered properly, or the wrong model was used. Okay, everything looks good. Let's put the back cover on. Before that, since this is an outdoor panel, we need to reapply the waterproof glue around the board edges. It is super important. Make sure to seal all four sides completely. Otherwise, rain can easily get in during the events. So make sure the glue sealed properly. Once that's done, we can go ahead and reinstall the back cover. When you're putting it back, make sure to get the direction right. The little arrow on the PCB should line up with the one on the back cover, both pointing the same way, facing up. See this arrow here on the board? Just match it with the one on the back cover, and you're good to go. Next, let's put the screws back in. Make sure to tighten every screw in. I'm not gonna show in detail here. If you leave any screws out, water will seep in through these holes, so don't forget this part. Once all the screws are back in, we can reattach the mask. Unlike when fixing LEDs, we can install the mask right away. No need to wait for the glue to dry. And that's it. The panel's ready to go back onto the cabinet.